Gasoline. It is the most widely used fuel in the world, powering hundreds of millions of cars, motorcycles, and small engines every single day. When crude oil is heated inside a refinery, it separates into different layers based on boiling point. Gasoline rises near the top of that process, collected at a relatively low temperature. It burns quickly and cleanly enough to work inside the small, fast-moving engines found in passenger vehicles. The version we pump at a gas station has already been blended with additives that help engines run smoothly and reduce harmful emissions. Without gasoline, the modern road system as we know it simply would not function. Diesel. It sits just below gasoline in the refining process, requiring slightly more heat to separate from the crude. Diesel is denser and carries more energy per liter than gasoline, which is why it became the preferred fuel for trucks, buses, trains, and ships that need to move heavy loads over long distances. A diesel engine works differently from a gasoline one. Instead of using a spark plug to ignite the fuel, it compresses air so tightly that the temperature alone causes ignition. This makes diesel engines more efficient, though they produce different types of emissions. Across much of Europe and Asia, diesel engines became standard in passenger cars for decades because of that efficiency advantage. Jet fuel. Commercial aviation depends almost entirely on a refined product called jet fuel, most commonly known as Jet A or Jet A1. It belongs to the kerosene family, sitting in a middle range of the refining process. Jet fuel needs to perform under extreme conditions: low temperatures at high altitude, intense pressure, and constant vibration. It has a very low freezing point and burns steadily rather than explosively, which matters enormously when an engine is operating miles above the ground. Modern jet engines are precisely engineered around the specific energy and flow characteristics of this fuel. Every commercial flight you have ever taken was powered by oil that started its life deep underground. Kerosene. Before electricity became common in homes, kerosene was one of the most important fuels in the world. It lit lamps across cities and rural areas throughout the 1800s and into the 1900s. Kerosene comes from the middle distillate range of crude oil refining, sitting between gasoline and diesel in terms of weight and boiling point. It burns with a steady, visible flame and is much safer to store than gasoline because it does not vaporize as easily at room temperature. Today, kerosene is still used for heating in some parts of the world, for agricultural equipment, and as the base for jet fuel. In many developing countries, it remains a daily household fuel for cooking and lighting. Liquefied petroleum gas. Most people know this simply as LPG and encounter it through the gas cylinders used for cooking and heating in homes around the world. It is made up primarily of propane and butane, two hydrocarbons that separate out during the early, lightest stages of crude oil refining. At normal atmospheric pressure and temperature, these gases float away, but under moderate pressure, they compress into a liquid form that is easy to store in metal cylinders and transport safely. When the valve is opened, the liquid returns to gas and burns cleanly. LPG produces fewer pollutants than many other fossil fuels, which is part of why it became a popular cooking fuel in places where natural gas pipelines do not reach. Fuel oil. Heavy fuel oil sits near the very bottom of the crude oil refining process. After the lighter, more refined products have been extracted, what remains is a thick, dark, viscous liquid that requires heat just to flow through pipes. It is not meant for cars or home use. Its place is in the enormous engines that power cargo ships, large industrial boilers, and power generation facilities. A single container ship crossing an ocean can burn hundreds of tons of heavy fuel oil in a single journey. Despite being the least refined of the major oil products, it carries a significant amount of energy and remains economical for applications where scale matters more than cleanliness. International regulations have pushed the shipping industry to use lower sulfur versions in recent years. Lubricating oil. Every engine, machine, and moving mechanical system needs something to reduce friction between its parts. That something is lubricating oil, and it also comes from crude oil, drawn from a specific fraction during refining. Without lubrication, metal surfaces grinding against each other would wear down within minutes. Lubricating oils are carefully refined and blended with chemical additives to make them stable across a wide range of temperatures, resistant to breakdown, and capable of suspending particles that might otherwise damage engine components. The motor oil you put in a car engine, the gear oil in a transmission, the hydraulic fluid in heavy machinery. All of these trace back to crude oil. Modern synthetic lubricants are partially derived from oil-based chemistry, even when they are engineered to perform beyond what natural crude could offer alone.